Hi folks, welcome to this video. We're going to have a look at the idea of further work on differential equations, in particular the topic of separating variables. Now there's a few notes in OneNote for my students and it's pointing you to watch this video here where we're going to have a look at three different examples, starting with this first one here. So this idea of separating variables, what's this about? Well, what you should notice about this particular differential equation is that on this right hand side we have both the x and y variable included in the equation here. And so to solve this, how are we going to solve this if we've got two separate variables? Well, the process is going to be that we're going to group the y variables together with dy on one side of the equation, and we're going to move the x variables together with dx on the other. So once again, we're using this idea in Leibniz's notation of separating these differentials here. Excuse me. Apologies about that. And so I think the best way to see what that means is to just work this through in this particular example. So I'm going to move this y minus 2 over to this side here. Now the operation between the pair of brackets is obviously multiplication, so we need to divide on the other side. And so if I divide on the other side, it's the same as multiplying by 1 over the reciprocal of this. So I'm going to write that as 1 over y minus 2 on the left side. I'm going to leave dy here with it. And on the other side, I'm going to leave the 4x squared plus 3. I don't really need the brackets anymore. I suppose I could leave them in though. And put the dx over with that. So what we've done here is we now have separated the variables. The x is on one side, the y is on the other, with the respective differentials. And so to solve this, what we're going to do is we're going to remove the differential by integrating. And we're going to do that on both sides. Okay, and so what's the integral then of 1 over y minus 2? Well, this is one of those rational functions, so its integral will be the natural log, absolute value of y minus 2. Now you may be thinking, what about a constant here? Well, let's put one in. Let's call this c1 for a moment. And let's now move to the other side and integrate that. So we're going to get 4x cubed over 3 plus 3x plus another constant. Let's call that c2. Now of course we could move the constants together on one side. So if we did, let's move them to the right hand side where typically the constants in this kind of work are put. And you might say, well, the constant's going to be c2 minus c1. Well, this c2 minus c1, that is just a constant. So to simplify things, we really could have just put one constant on the right hand side, and our answer is not written with two constants, it's just written with one. Okay, and yeah, that would be just one single constant. So there was no need to really have put the c1 and c2. We could have just put this constant on the right hand side straight away. No need to muck around with constants like this. And that's what I'll do in the future questions. Now you may be wondering, okay, what do we do now? How do we get y on its own? Well, with these questions on separating variables, this is actually the usual stopping point. After you finish integrating both the left and right hand side, unless there's a particular reason to make y the subject, you wouldn't. You would basically stop at this point here. Okay, so that's what I'm going to do. Okay, so this is the typical way that you'll see the answers, and as you work through the exercises in your workbook, that's usually how you'll see your answers put. Okay, let's move on to a second example. just going to pause the video for a moment just to grab that example. Okay, so let's continue. I've got the second example now, and I've written the question out here. Okay, and so what this one is saying is we want to find the solution to this particular differential equation here. One of the key differences is, apart from the fact that we've got an exponential function in here, is that we're asked to find a particular solution. Now you might recall from other work that that means finding the constant of integration, and we need more information to be able to do that, and here we've got x equals 3 and y equals 0. So let's work this one through. So starting from here, rather than rewriting that again, I'm just going to do the same thing as I did on that example over on the left here, move the things involving y over here with dy, and any constant and the x squared here I'm going to leave on this right hand side. So what would that look like? Well, I'd have 1 over e to the power of y on the left with dy and 6x squared dx on the right, and to get rid of the differentials to solve this we're going to integrate both sides. Well, the integral of this, in fact I will just rewrite this as e to the power of negative y dy, and this right hand side I'll just wait to integrate that as well. Okay, so what is this going to equal? Well, you might recall that the integral of e to the power of y dy would just be itself. So e to the power of negative y, this doesn't look too good, let me just fix that up. Well, it's not going to be itself, because when you derive this you'd have a negative in front from the chain rule, so we'd need a negative in front there to balance that. So if you derive this, you get negative e to the power of negative y times negative 1, and the negative 1, negative here, and the negative 1 would cancel, leaving e to the power of negative y, which means that this is the correct integral then. Okay, so I'm going to leave it like this. I'm not going to put a constant, because the constant integration I'll put over on the right hand side here. Okay, integrating this would become, and I'll just do a little bit of work to this side, 6x cubed over 3, and of course the constant, but I just wanted to indicate that that would simplify to 2x cubed. So I'm going to go straight to that, plus our constant. Okay, what to do now? Well, we're after a particular solution. Okay, and one other thing that I should have made clear, that was part of the original question that I forgot to put down, make y the subject, was also part of the instructions. So what I'm going to do is I'm going to find c and then make y the subject of this. So what I'm going to do with this part here, I'm going to rewrite this as negative 1 over e to the power of y. Might be a little bit easier to work with, not very much, but a little bit. And let's now substitute in the 3 and the 0. So we're going to get negative 1 over e to the power of 0, because y is 0, and x is 3, so we're going to get 3 cubed. 3 times 3 is 9, 9 3 is 27, 2 times 7, that looks like that's 54. Okay, so we've got 54 plus c. Now this is not 0. Remember, e to the power of 0 is equal to 1. So we've got negative 1 equals 54 plus c. Well, c must be 55. Okay, otherwise 55, no, it can't be 55. C would have to be negative 55. So negative 55 plus 54 would be equal to negative 1. Okay, so just coming back to this constant integration, yes, I just wanted to check on something there. Certainly c is equal to negative 55. Okay, so coming back to our question, and we need to substitute that in and make y the subject. Just going to make a bit of room on the right hand side here. So coming back to, say, this point here where we can now substitute c in, would have negative 1 over e to the power of y. In fact, I'm just going to use the line down, equals that 2x cubed minus 55. Okay, now to make y the subject of this, there's a number of different ways this could be done. What I'm going to do is I'm going to remove this negative here, and I'm going to multiply each part of this equation by negative 1. It's a little bit easier to work with positive left hand side here. That would become positive 55, this would become negative, so I'm going to put this as 55 minus 2x cubed. At this stage, what I'm going to do now is move the e to the power of y over here and then this over to this side, because I want to get e to the power of y on its own. And to get rid of that exponential, we can take the natural log of both sides. And so there we have a solution. Now if you look in the answers to the workbook, you'll notice that this is not quite what they've got. They've got y equals negative natural log of 55 minus 2x cubed. So as an exercise, I'd ask you to look at how you could transform this into this solution here using a little bit of algebra to rewrite that as a negative indice, then using one of the laws of logs to see if you can see why this would also simply be another form of this answer here. Now in my opinion, both answers are perfectly fine, and I would accept that and obviously that. Okay, so we've got our second example done. Okay, I'm going to move now on to a third example. Okay, so folks, in this third example here, which I've written up, we've got another equation here. It looks a little bit more complicated. A couple of y variables or occurrences of the y variable and x, and we've got this extra information here, which will hopefully allow us to find the constant of integration. So don't be too put off by something that looks initially a bit complicated. Let's try the first thing to make this a little bit easier to work with. I'm going to get rid of the fractions. I'm going to cross multiply here. And I know that hasn't separated the variables in one go, but not everything happens in one step. Now we've got y with dy, and then we've got this other y term over here, so I'm going to move that over to here. So if we do, we'd have this y on top over 1 minus y squared dy, and on the right we'd have x on top and would have to divide by 1 minus x squared, and so we get to that point, and yes, there's nothing stopping us now integrating. Now this is one of those another situations where you've got a function of something, let's say x on the bottom, and a derivative of that function or some multiple of that on top, and then when you integrate that, you might recall it was the natural log absolute value of fx and a constant. Just recall that sometimes this constant we can say might be, say, the natural log of something else, and so we could rewrite this as, sorry, it's getting a little messy, I'm trying to write too quickly. And then you can use that law of logs that says if you've got the log of a plus log b is equal to log ab. So this could be rewritten as natural log k, absolute value, once again messy, k absolute value fx. And that's what's going to actually occur in this as well. The first part though, notice that the derivative of the bottom would be negative 2y. So I want to have a negative 2y on top. And what I've done there is I've introduced a constant of negative 2 into this left hand side. And I need to balance that out by saying, well, I'll need to have negative a half out the front. If negative a half times negative 2 would be positive 1, and it would be equivalent to what we've got here. But now on this left hand side we have a function on the bottom and its derivative on top, and we'll integrate that in a second. Now the right hand side is exactly the same, except it's in terms of x. So I'm just going to put exactly the same working, but with the x variable. So what will this be? This will be negative a half natural log absolute value of 1 minus y squared. And on the right hand side, exactly the same thing, but we have our constant. Now, as I discussed before, I'm going to get rid of this c here and replace it with a natural log in a moment. But before I do that, I want to get rid of this negative a half. I've got a factor of negative a half here and here, so I could multiply every single part of this equation by negative 2, including the constant, and 2 times the constant is just another constant. So this would become that, multiply that by negative 2, multiply this by negative 2, multiply that by negative 2 is simply another constant. Now I'm going to replace this with natural log k, and I'm going to combine these two, and hopefully you can see why I'm doing that, because then we're going to have a natural log on the left and a single natural log now on the right. And when you've got a single natural log on both sides, you can then take the exponential. Just be careful doing that. I have seen students over the years have something like this. We've got natural log a equals, I know on this other side here, natural log of b plus, I know, something. Let's call it q. And they say, okay, well let's just take the exponential of each part here. So let's just go e to that, e to that, e to that, and that's going to give me a equals b plus some exponential to the power of q. Well, that is not true. You can check that by, I don't know, trying some values in here that make the left side equal to the right side, then try and take the exponential of each part there. You can take the exponential of both sides if you have natural log of something equal to the natural log of something else, but a single log here and a single log here. Okay, so bear that in mind. That is why we did that work, to bring that constant of integration, okay, into this natural log statement. So now taking the exponential of both sides would have 1 minus y squared equals k bracket, let's put 1 minus x squared. Okay, now there was a further reason why we wanted to get rid of that natural log, and that was if you're using if we know that 2 3's on this curve that has y related to x, if you put 3, let's say, into this here, you'd have 1 minus 9 equals negative 8, and you can't take the natural log of negative 8, it doesn't exist. So we'd have to get rid of those natural logs before we could actually even find the constant, and now we can. So substituting the 2 3 in, we're going to have, okay, using x equals 2, y equals 3. Now I'm running out of room on my stylus here a little bit, so I'm going to move my working over to here now, just a little easier to write for me. So I can have 1 minus 3 squared would be 9 equal to k bracket 1 minus 2 squared would be 1 minus 4. So we'd have negative 8 equals negative 3k, and if you solve that you get k equals negative 8 over negative 3. The negatives would cancel and you'd have 8/3. And so therefore we've got 1 minus y squared equal to 8/3 bracket 1 minus x squared, which is a perfectly acceptable solution, except nothing except we're not asked to make y the subject of this one. So yes, we could leave it at this point. And I think if you check your workbook, you actually see that this is question 250 that I've done here, and this is the solution that's at the back of the book here. Right, so we covered quite a bit there, a bit of work on logs, combining the constant integration into a natural log statement, and yeah, hopefully those will be helpful when you come to do the questions from your workbook. Right folks, we'll see you in class. Enjoy.